In this lesson, we're going to look at solving trig equations. We're going to be doing these solvings by hand. Each and every one of these problems is going to turn into a special angle for us. So this is, again, where we're building back from that first portion of our trig unit at the beginning of chapter 13, where we learned about some special triangles with our 30, 60, 90, and 45, 45, 90. They're going to become important to us in these problems. So in these problems, these are our steps that we're going to go through every single time. The first thing we're going to do is, just as if solving a regular algebra equation, we want to get our variable alone. You're trying to solve for x usually. So we're going to try to get the trig part of this alone. So sine of x equals a number. Whatever that trig part is, that's our first step, is to use algebra, adding, subtracting, multiplying, dividing, to try to get the trig part alone. Then we're going to use SOHCAHTOA to find a type of angle for our answer. We're going to be solving these problems in radians, not in degrees. Then the next part says figure out which quadrants the answers lie in using this rule of ASTC, and I'll go through that in a second. And then our last step is we're just going to tag in this plus 2 pi n to the end of our answer, and I'll explain why as we go through a problem. So these are our general 4 steps to solving the problem. Right? Every time we're going to do these same exact 4 steps. So our first step in solving the problem is to try to get the trig part alone. So first thing I'm going to do is add 1 to both sides. Then I'm going to divide both sides by 2. And that's step 1. Every time, get the trig part alone. Add, subtract, multiply, and divide to get whatever the trig function is, sine, cosine, tangent, cosecant, secant, cotangent, whatever the trig function is, get it alone. Our second step says that we want to use SOHCAHTOA to find our type of an angle. So what is SOHCAHTOA for sine? Opposite over hypotenuse. So if I need a hypotenuse of 2, what kind of a triangle am I working with? 30, 60, 90 for a hypotenuse of 2.
Oh.
And if I want to be opposite of the 1, what angle are we pointing to? The 30 is the one that is opposite of the 1. We're going to be working these problems in radians. So our conversion is that 180 is equal to pi, and 180 divided by 6 would be 30. Okay. That's step 2. This is stuff up to this point that we did back in that first part of the trig unit back in chapter 13, and then now we're going to take it a couple steps beyond. The third step said figure out which quadrants the answer lies in according to this rule of ASTC. So I'm going to show you what this rule means. So there are 4 different ways to draw a triangle with a 30-degree or pi 6 angle. I could draw that triangle up in the first quadrant, second quadrant, third quadrant, fourth quadrant. There's 4 different ways I could draw that triangle. In the first quadrant, all of the sides of the triangle are positive. The hypotenuse is always positive. It's on the right-hand side, it's on the up side. So every one of those sides of the triangle is positive, which means any way I would divide those signs for SOHCAHTOA, I'm going to end up with a positive answer. That means all of our trig functions are positive in that first quadrant. No matter how I divide those sides, opposite over hypotenuse, opposite over adjacent, it doesn't matter. They're all positives. In the second quadrant, hypotenuse is always positive. The up is positive, but this horizontal side is negative. So in that quadrant, anytime I use that adjacent side, I'm going to get a negative answer. So sine is opposite over hypotenuse. That uses both the positives. But cosine and tangent both use an adjacent. They would both end up as a negative answer. So our only positive one in that quadrant is sine. Because if I do adjacent over hypotenuse, I'm going to get a negative. If I do opposite over adjacent, I'm going to get a negative. So the only way to end up with a positive answer in that quadrant is if I do opposite over hypotenuse.
Do we have to do that? Like, is that for the answer?
This is the ASTC rule. So instead of just memorizing random letters and not knowing what they mean, this is what our letters mean. Down in the third quadrant, we're still going to be using that same horizontal negative. Our vertical is also negative, but our hypotenuse is positive. So in this quadrant, which trig function would give me a positive solution? Tangent. It's kind of tricky because tangent uses both of the negatives, opposite over adjacent. A negative divided by a negative gives a positive answer. Otherwise, if I do a sine, I have negative over positive. If I do a cosine, I have negative over positive. So the only trig function that's positive in that quadrant is when we use both the negatives. Negative divided by negative is positive. In the fourth quadrant, you can probably guess how it's going to turn out because we only have one left over, right? But we're going to have a negative for our downside, positive for the hypotenuse. So if I want to get a positive solution in that quadrant, I need to do the adjacent in the hypotenuse, which is the cosine. So our rule then is we say A, S, T, C going around for our quadrants. That tells you which trig function will be positive in each quadrant. A lot of math teachers use the phrase to try to remember the order of these letters. All students take calculus. I hate that because it's not true. So you might as well just come up with your own story of remembering those letters in order. A, S, T, C going around tells us which trig function will be positive in each of those quadrants. Okay, and then you don't have to go to the trouble of drawing out all those triangles every time if you can remember that A, S, T, C rule. So how that builds into our problems then is step 3 says we need to figure out in which quadrants our answer belongs. Your answer will always be either 2 quadrants or 4 quadrants. Okay? This problem says that we want sine to be a positive 1/2. So in which 2 quadrants is sine a positive value?
All and sine.
The all quadrant and the sine quadrant have a positive sine value.
So all is,
Means that all of the trig functions are positive. Sine, cosine, and tangent all
but
positive.
like when we do this on every equation, you're gonna have like either tangent, cosine, sine, and then you're also gonna have all.
If our fraction turns out to be a positive number, but sometimes in that equation it might actually be a negative, so then we'd want to think about opposites. But yes, yeah, we'll be picking all and one of the other ones. So now we need to figure out what the answers are in those quadrants. So when we graph in radians, we learned that we divide each half of the circle into the denominator number of pieces. So our denominator was 6 on this one. For pi over 6, so I'm going to cut that top half into 6 pieces. My first angle in that first quadrant is just going to be the pi over 6. It's one piece around. In the second quadrant, I want to come all the way around to that last piece, which is 5 pieces around. Our final step says throw a plus 2 pi n onto the end of this thing. What that means is we talked about coterminal angles back in chapter 13, and we said I could go just here and be done with it, or I could go like around and around and around and be done with it, right? So each circle is 2 pi. So this plus 2 pi n just means, and you can go around in circles if you want, okay? Each 2 pi is a circle, so it just says you can go around another 1, 2, 3, 4, 5 circles, and it doesn't matter. Okay, so we just throw that plus 2 pi in onto the end of our answer.
Where did the 5 pi over 6 come from?
The answer in the S quadrant, we begin counting here, and we go around 1, 2, 3, 4, 5 pieces to get to that final triangle.
But where did that come from? Like, how do we know how to do that? How to go 5?
We want an answer in the S quadrant. And we cut each half of the circle into 6 pieces. And back in chapter 13, we learned we always connect down that last piece to the x-axis. So just we want to count out to that last piece.
Why do you have an answer in the A and the S section?
Because we want sign to be equal to positive 1/2. And that'll happen when all are positive, and that will also happen when sign is positive.
So you won't always have 2 answers?
You will always have 2 answers or 4 answers.
Oh, really?
So never 3.
Never
So
3
1.
answers or 1 answer. Always 2 answers or 4 answers.
Sounds fun.
First step on this one,
Nice.
get the cosine alone. So I'm going to do that by subtracting 1. And dividing by 4. So that's step 1, get your trig function alone. Step 2, use SOHCAHTOA to figure out what kind of a angle this is. So cosine is adjacent over hypotenuse. Which triangle has hypotenuse of 2? 30, 60, 90. And in that, which angle is adjacent to the 1?
60.
The 60 is right next to the 1. We're going to be working in radians. 60 is 180 divided by 3. So that's step 2. Figure out what kind of angle we're working with. We're working with pi-thirds angles. Step 3, figure out which quadrants this answer belongs in. So according to ASTC, I want, in this problem, cosine to be negative 1/2. So when you think about where cosine is negative, these letters tell us what is positive in that quadrant, and everything else would be negative. So all means all are positive. I don't want that because I don't want a positive, I want a negative. C means cosine is positive. I don't want that because I want cosine to be negative. So that means my answer belongs in the S quadrant and the T quadrant. For pi-thirds, we learned that we cut each half into 3 pieces. So in my S quadrant, to get to the angle there, I will have gone around 2 of those 3 pieces. And in the T quadrant, I will have gone around 4 of the pieces. And our final step is to just throw that plus 2 pi n onto the end of our answers always. And that just means you can keep on going around in circles, and as long as you land at that same place, you're still getting the right answer. We can think about that in terms of the graphs that we learned how to do. They do those wave things forever, so it's going to keep on hitting the same points over and over and over forever since it keeps on doing that same wave. First step, get the trig function alone. So I'm going to start by adding 1. Dividing by 2.
Are they all going to be 369? Right?
No.
Oh, okay.
Good question, but no. They'll all be 30, 60, 90, or 45, 45, 90. They'll all be a special triangle. We're not actually quite done getting our trig function alone, because there's still something being done to the trig function here. So what do I need to do to get it to be just sine?
Square root.
Take a square root of both sides. Now when you take a square root of a fraction, we learned we can take the square root of the top and the square root of the bottom. And what else did we learn we need to do when we take a square root in an equation? We're going to leave square roots
Oh,
on the
plus.
bottom here.
Plus
And minus. Technically, to be like really precise about our answers and all perfectly like grammatically correct, so to speak, we shouldn't have square roots in the bottom. But for trig, we really kind of need them there. That's going to help us be able to evaluate. But we do need that plus or minus. Okay, every time you take a square root in an equation, you need a plus or minus.
In the book, will they be like expecting us to have changed it?
Well, this isn't our final answer yet, so this won't be in the back of the book.
No,
Because
I
we're
mean
not
like
sure.
if they were figuring it, would they have changed it?
No, because where we need to go from here, we actually need it in the bottom.
Okay.
So first step, get the trig function totally alone. Remember plus and minus if you're taking a square root. Second step is thinking about SOHCAHTOA. So sine is opposite over hypotenuse. Where do we have a hypotenuse? A square root of 2. The 45, 45, 90. And so our angle then, opposite of a 1 in either one, the only angle in here is 45, which is 180 divided by 4, so pi over 4. Third step, quadrants. This equation says that sine could be positive or negative. So sine is positive with all and sine. It is negative in the other ones, and we're okay with that too. So you will always get either 2 answers or 4 answers. You will get all 4 quadrants when in the equation we need to take a square root and we get a plus or minus. Okay? If we get a plus or minus in our equation, that means all 4 quadrants are going to hold answers for us. So if our denominator is 4, we're cutting each half of the circle into 4 pieces. In that first quadrant, we're just going 1 piece. So pi over 4. In the second quadrant, I'm going around 3 of those pieces. Down in the T quadrant, or the third one, I'm going around 5 of those pieces. And over in the C quadrant, I'm going around 7 of those pieces.
Can you just like put those in parentheses and put plus 2n?
Yeah, and then we can just kind of write like plus 2 pi n. I'm alright with a little bit of laziness.
Can you go over the SATC thing? How, I just don't get how we get there.
So those letters tell us which of the trig functions are positive in each of those quadrants. So in this problem, I want sine to possibly be positive. So that would happen in our A quadrant and our S quadrant. That's where sine will give us positive answers for opposite over hypotenuse, the way we would draw triangles there. But our equation also says that sine could be a negative, and that will happen in the other 2 quadrants. So when we have that plus or minus, we're going to end up having all 4 quadrants.
Is that the only time?
That's the only way we're going to end up getting all 4 quadrants is when we get a plus or minus. These directions change just slightly. They say in here, on the interval 0 to 2 pi. What that means is, we don't want to keep going around and around and around in circles. We just want to take our first set of answers. Everything will be exactly the same, except we are not going to do a plus 2 pi n at the end. We'll do everything the same through step 3, but then just at the end, we don't put that on the end of our problem, because this means we just want to look at that first set of answers and stop. Okay? Everything else is exactly the same about it. So first step, get the trig function alone. So I'm going to add 3 to both sides. Divide by 4. And take a square root. When we take a square root, we get a plus or minus, and we take the square root of the top and the square root of the bottom. Step 2, use SOHCAHTOA to figure out which angle this is talking about. Cosine is adjacent over hypotenuse. So hypotenuse of 2 is which triangle? 30, 60, 90. And adjacent to the square root of 3 is the 30. 30 is 180 divided by 6. Last step is figure out our quadrants. This equation says we want cosine to be positive or negative. So cosine would be positive in A and C. It would be negative in the other ones. And we're okay with all of that. Pi over 6 says that we're going to divide each half of the circle into 6 pieces. And we always want to go to the closest piece within the quadrant to the x-axis. So in this first quadrant, I'm just going to go 1 piece. So 1 pi over 6. In the second quadrant, I'm going to go to the last piece before hitting the horizontal, which is 5 pi over 6. And then I'm going to go just beyond that horizontal, which is 7 pieces. And then I'm going to go almost all the way around, which is 11 pieces.
So you want to stay close to the x-axis.
You want to stay close to the x-axis.
Yes, I can't count for sure.
Sure.
Yeah.
So on the interval thing is nothing to do with except for the.
Yeah, it doesn't change anything about the solving the problem. It just means at the end, don't say plus 2 pi n.
Okay.
That's the only difference that makes, is we just don't want to do that plus 2 pi n, because this means we only want to look for our first set of answers. The plus 2 pi n just means we're going to keep on going around, and we don't want to do that here.
So when it's all the way around, you don't want to do the 2 pi.
When it says on the interval of, then we don't want to do the plus 2 pi n. If it just says solve, then we want to do it. Alright, so first step is to get the trig function alone. We do that here by subtracting 1 from both sides. Second step is we want to figure out SOHCAHTOA. So for SOHCAHTOA we need a fraction, and tangent is opposite over adjacent. Which triangle has both an opposite and an adjacent of 1? 45, 45, 90. So our angle is 45, which is 180 divided by 4. For our quadrants, this problem says that I want tangent to be negative. These letters tell us which trig function is positive. So A means all are positive, and I don't want a positive, I want a negative. T means tangent is positive, and I don't want tangent to be positive, I want tangent to be negative. So my answer must exist in the other 2 quadrants. We'll always have 2 or 4 answers. 4 if we took a square root to get a plus or minus, 2 otherwise. Pi fourths means we're going to cut each half of the circle into 4 pieces. To get into the S quadrant, I need to go around 3 of those pieces. To get into the C quadrant, I need to go around 7 of those pieces. And since this says on the interval, we don't need a plus 2 pi n. So pay attention to the directions in your homework. Some of them, when it says find the general solution, that means just throw the plus 2 pi n onto it. When it says on the interval of, don't put the plus 2 pi n on it. If you check your answers in the back of the book, it is possible that their answers are going to look different than ours. They take it one step beyond and say, sometimes there's a way to combine these two answers together, and instead of adding 2 pi n, maybe only adding a pi n. I don't want to do that with us. I want it to be the same every time, so just know that when you check your answers in the back, you might have more answers than what it looks like they have. And that's because they might have smushed some answers together, and instead of adding 2 pi, maybe they only added pi, or maybe they only added pi halves, or something like that. So sometimes they combine answers together in a way that we're not doing. So be aware of that. I'm saving us one step of work. This problem doesn't actually work, so
Yeah, I was just starting to do it.
yeah, it turns out to be a non 30, 60, 90 or 45, 45, 90. One other thing you need to remember is something like square root of 3 over 3. We can't do SOHCAHTOA on that because those numbers aren't in there, but this is really the same thing as what? 1 over square root of 3. Okay? This is unrationalizing or unfixing the denominator. So if you see a square root of the same number on the top and the plain number on the bottom, that's really 1 over the square root of that number. So you might have to do that in a problem or two as well to kind of unfix a problem.
How do you know it's